Okay, good morning. Welcome to
Counting number 25a.
Counting25a. So yesterday we talked about the number of three-digit integers that had descending numbers, and we did it two different ways. Do you remember?
I think it was the casework way and the choosing number way.
Yeah, and how did the casework way work?
So we looked at we looked at the 100s, the 200s, the 300s,
Okay.
and figured out how many there were for each set, and
Okay.
then added them up.
Now the tricky one. Do you remember how many there were for each of those sets?
I think it was 120.
Right, but in the each individual set.
For the first one there was 1, then
Yeah.
there was 3, then
Wasn't it 6, then 10, 15, 21?
well, it was 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4.
Ah,
1
okay.
plus 2 plus 3 plus 4.
Okay, and what are those numbers?
Those numbers are there. So there was 1 in the 200s.
Yeah.
Wasn't it 1 plus 2? There's 1 plus 2 in the 300s, 1 plus 2 plus 3 in the 400s, 1 plus 2 plus 3 plus 4 in the 500s, and
Okay,
so on.
and so what are those actual numbers? What numbers did you add up?
Those are the number of descending numbers in each case.
Yes, but what are the actual numbers that you added up?
So 1,
Yeah.
3, 6, 10, 15, 21, all the way up to, I think it was 45.
Okay. So I've written down Pascal's triangle. Do you see those numbers anywhere that you
Well,
added up?
I think I see them. So I see the 1, the 3, the 6, 10, 15, 21.
Oh.
Those numbers.
And what was the next one?
And then there's
28.
28, 36, and 45.
Those numbers. So this column going down.
Okay. And so now we have one little question of did we get to 45 or not?
Well, no, I don't think we did.
Okay.
No,
Because the 1 was in what?
It was in the second one, so everything had to be shifted over.
So the 1 was in
The
where?
200s.
In the 200s.
300s, 400s,
500s,
600s,
700s,
700s,
800s,
800s,
900s. Okay, so we didn't
So
get
didn't
to 45.
quite get to 45.
But it's interesting that we had a row of Pascal's triangle there, or not a row, sorry, we had a,
Part of
what would we
Pascal's.
call that? Part of Pascal's.
Well, it's not really a diagonal.
Well, it's down to the third one on the left side. Then you
Uh-huh.
go down from that.
Okay.
Well, we could call it like a chord of Pascal's triangle.
A chord, yeah.
Because it's sort of like a chord in a circle.
It is sort of like a chord in a circle. That's a good name for it, actually. And what was the other way of counting our descending numbers?
Well, we were choosing. We chose the descending digits.
Okay. So how did we do that? What was the method?
We figured out that for each 3-digit number, there's 6 other numbers or 5 other numbers, or 6 total, that you can make out of the digits.
And only one of them is in descending order.
Uh-huh.
Except for the ones that repeat digits.
Right, so we need to make sure we choose distinct digits, and that's why it was important to say it was strictly descending.
Yeah.
So what did we do then, once we made that observation?
Then we figured out how to choose it, and then to choose a number, there were 10 digits, and we had to choose 3 distinct ones.
Okay,
So it was 10 choose 3.
all right, and where is 10 choose 3
So it's
on
10,
our Pascal's triangle?
Well, it's 10 down to the 10th row, and then 4 over. 1, 2, 3, 4, 20.
Right. Okay, interesting. So do you see any way that the numbers we saw before, which also happen to add up to 120, relate? Here, so we have 1, 3, 6, 10, 15, 21, 28, 36, and then we have 120. So how do they relate to each other?
Well, is 120 divisible by all of them?
That's a good question.
It's divisible by 1, it's divisible by 3 and 6 and 10. 15, well, it's divisible by 3 and 5.
Okay.
And
21, no.
7.
No 7s.
No 7s and no 20, all right.
else could that be it? Well, it's on a different chord of Pascal's triangle.
Ah, which one is it on?
It's on this chord here, going down.
Goes down. How far do you have to go down to get to get to 120?
Well, looks like you have to go 4 down.
4 down.
Oh, all right. Let's move on to the next one.
Okay.